12.4, simplify rational equations. I think this is probably the lesson that you guys did the best in the entire chapter. So I'm going to go through this pretty quickly and get to 12.5 and 12.6 that I need to spend a little more time on. Let's look at 16. And the instructions right here are just finding the excluded values. So all we need to do is find excluded values. Nothing else yet. So if I have x plus 3 over 2x minus 4, if you remember, the excluded value is the value that makes the denominator 0. Well, this is exactly the same as finding the solution of the equation, or what we call the zeros of the function. In order to solve that, you just need to set the denominator to 0 and then solve for x. 2x equals 4, x equals 2. So if I put in 2 for x, I know that that denominator is going to be 0. And of course excluded because you can't divide by 0. So my excluded value is 2. Let's try it for another problem. I have 8 times z divided by 9z squared minus 1. Okay. Now you could look at this a couple of ways. Some of you will look at this and say that you will be able to see that as long as this 9z squared value is 1, because you want 1 minus 1 is 0, that means that whatever z squared is must equal 1/9. And you can backtrack and say, okay, that's either got to be 1/3 or negative 1/3. That's a little hard to do. But that is one way. You can just try to think through it. You could also just do what we've learned before and set 9z squared minus 1 equal to 0. And if you remember, we're just trying to solve for z, right? Find the 0 of the function. Well, there are two ways we could do this. We could do square roots and have 9z squared equals to 1. Take the square root of both sides, right? And you'll end up with 3z equals plus or minus 1. And then divide by 3, and you get plus or minus 1/3, which are the two excluded values, just like we talked through it just then. Or you could do it using factoring. 9z squared minus 1 equals 0. And this is a difference of two squares. So 3z minus 1, 3z plus 1. So 3z minus 1 equals 0. 3z equals 1. Z equals 1/3. And you do the same thing over here and get z equals negative 1/3. And again, you're going to find that same answer, plus or minus 1/3. So these are all the excluded values for the denominator. You just find the zeros of the function. And those are going to end up being your excluded values. Second portion of 12.4 was just to simplify the expression. So I'm going to do number 20 with you. And so different instructions. This is simplify the expression and state the excluded values, if any. State any excluded values. We're going to do number 20. 3n squared minus n minus 2 over 2n squared minus 3n plus 1. Well, our first step when we simplify is to factor. So I'm just going to put that step up here as a reminder. We're going to factor top and bottom, hoping that we can do that and then we can reduce. To factor 3n squared minus n minus 2, 3n, n, and unfortunately we're limited. 2 is either negative 2, positive 1, or positive 2, negative 1. If I put a 1 here and a 2 here, the difference is 1, which makes sense. I want the bigger number to be 3 minus 2, so I'm going to put a negative 1 here because I get negative 3n, positive 2 there because I get a positive 2n. And if I remultiply it, I can get this back, so you can always know if you've done it right. Now I'm going to look at the bottom and see what I can do. Well, I'm going to have 2n here and here. This is easy. Plus 1 plus 1. It either works or it doesn't. 2n plus 1n. Oops. I was wrong. Negative 1 minus 1 minus 1. Because I need a negative 3n. There we go. Okay. So now that I've done that, I've factored both. And my next step is to do any canceling that I can. Well, I can cancel n minus 1 and n minus 1. And once I've canceled, I'm left with 3n plus 2 over 2n minus 1. Now I'm not quite done because the one thing I have not done is state the excluded values. This is incredibly important. To state the excluded values, you have to go to the expression before canceling. Because if you wait till after, you're only going to get one of them instead of both. So you have to look at this expression before canceling. So look at expression before canceling to find all excluded values. Very, very important. So here, 2n minus 1 equals 0, 2n equals 1, n equals 1/2. There's 1, and there's my other. N minus 1 equals 0, n equals 1. So I have two excluded values. N equals 1, n equals 1/2. And notice that if I had done it here, I would have only gotten the n equals 1/2. Okay, that finishes 12.4. And I'm going to move right in and do 12.5. And actually, no, I'm going to stop the video because it's going to get too long. So I'll catch up with you with 12.5 in just a minute.